So for this demonstration, we're going to look at the what a rate law would be based on initial rates. Okay, so this is where we would need a table of information. This would be given, and it's our job to come up with a rate law that would look something like this: R equals some constant K times the concentration of NO2 times the concentration of F2, this raised to some variable, this raised to some other variable. We're going to try and figure out what K, X, and Y all are. All right, so in order for us to do that, what we need to do is pick one of these to start with, and I'll just pick what comes first, NO2. So I'm going to look for a pair of trials where NO2 changes and F2 doesn't. So this is an example of that. NO2 changes from 0.2 to 0.1, and F2 stays the same between these two. So here's what I'm going to do. I'm going to pick trial 2 first. So trial 2, I'm going to divide that by trial 1. So what that means is my rate of 0.051 is equal to some constant K times 0.2 raised to some variable times 0.1 raised to some variable. And I'm going to divide that by trial 1, which is 0.026. That's equal to some constant K, and it's 0.100 raised to the X and 0.100 raised to the Y. And I'm going to divide one by the other. My K's will cancel, as will these. So when I go through and do this, this number becomes about 2. And this becomes 0.2 divided by 0.1, which becomes 2, and that's raised to the X. And here X must equal 1. Okay, so that means that I've found this number. Now in green, I'll do another trial. So what I'm looking for now are trials where NO2 stays the same, but F2 changes. And trials 3 and 2 do exactly that. So 0.103 is equal to K times 0.200 over X times 0.200 to the Y, and then 0.051 is equal to some constant K times 0.200 to the X. And since I know X is 1, I could put 1s there, but you know, it's going to cancel anyway. To the Y, my K's cancel, my X's cancel. This comes out to be about 2, and so I've got 0.2 divided by 1, which is also 2 raised to the Y, so Y is equal to 1. So that means that my rate law is R equals some constant K, NO2, F2. Okay, I could put the 1s there, it won't really matter. These things raised to the 1. So that is the rate law. And now all I need to do is find the value of K. Fairly straightforward. I can pick any of these trials that I want to work with. So I'm just going to pick the first one here. They're all equally good. 0.026, and that's molar per second, is equal to 0.100 molar times 0.100 molar. Oh, it should be inside the parentheses there. And then some constant K, which is usually at the front. I'm just going to put it at the back. There's no real reason. And all I need to do is figure out what units K must have in order to come to units of molars per second. So right now, I've got molars squared, and somehow that needs to equal moles per second. And so the way that this ends up working is if this gets multiplied by moles to the -1 seconds to the -1, that must be the units of K, because that'll be m squared times m to the -1 is m, s to the -1 is over s, so that works out. And now 0.026 divided by these two numbers comes out to 2.6, yes, and it's m to the -1, s to the -1. So if I really wanted to write my rate law again, it's 2.6 m to the -1, s to the -1, NO2, F2. Okay, relatively straightforward way of using instantaneous rates to arrive at a rate law.